What was the new frickin' file that I added? Sometimes I add new source files and I don't remember what they are called. Make definers, that's what it's called. I'm getting hungry. Might have to make some eggs. Before everybody shows up. So today, sometimes I work on software for a long time and things get really complicated and gnarly and hard to understand in some parts of it. And then one day I wake up and I go like, wait, I was just being stupid and this is way easier than I am making it. And on a particular topic involving polymorphism stuff, I had that waking up and realizing that someday earlier this week, but I didn't want to rewrite it yet. But today I was like, we don't have to turn on the new version, but let's like kind of plug it in and just see how much of it we can do and just see what it's like, and maybe I'll yeah, because there's still two things in the compiler that are too fucking complicated, at least. One of them is the polymorph system, even though it's a lot simpler or more manageable than it used to be. And the other one is macros. And with the polymorph system, I realized what the problem is. It's like I decided very early on, in fact, my first decision about how to implement this was done a certain way because it seemed like this other idea that I had was totally wrong and ugly and bad. And the idea that I judged early on as being wrong and ugly and bad is actually correct and simple. Whereas the way that I ended up doing it over time is not really correct. That causes a lot of problems in terms of me trying to make it correct. I mean, anything can be made correct, right? It's just gross. And then, yeah, complicated. So I saw a way to simplify things, and I'm hoping. So sometimes I see a way to simplify things, and then I start doing it, and then it turns out I was wrong, and you can't actually do that. But I'm hoping that doesn't happen here. I'm hoping I can just do the thing. So we'll see. Correctness with the fewest moving parts possible. Yeah, it's something like that. You know, it's like it's like you're designing a piece of field equipment and people need to bang it around in the mud and stuff, and it needs to not break. Right? But banging it around in the mud is also equivalent to like you coming back to this code a year from now. or trying to pass it on to somebody. What console out of the big three? Who gives a shit? I don't care. None of them, they're not hard to develop on compared to the old days. Suppose I like made some bacon earlier in the week and I put the rest in plastic wrap in the refrigerator. How do I know if it's still good? How do I know if it's dangerous days to eat the bacon? And the sloppy bacon. Oh no. Sloppy bacon. Okay. Since I had another snack available, we are not going to attempt the bacon yet, but we may do it later. 5 or 6 days. That might be about how long it's been. It's 5 or 6 days. maybe a little bit less, maybe 4 days. I have lost all track of time, honestly. Okay, we're binding definers. No. Yes. We're going to have to pass additional arguments to this. But for now, let's just change the name. Instead of result, this is going to be our new code that we call to match polymorph variables. Okay, so the idea is in this non-looping, I want to replace this check that types match, which I believe is the only one in the non-looping. Yeah. This check that types match, we don't want to call that here. Instead, we want to pass like a pointer to state sub inputs, state arrow inputs sub I into this thing, and instead of results, we'll like store the results on there. Something like that. The deal is, okay, I'll try to explain. I know you guys are not like all up on compiler internals, but the deal is, previously, when you're doing a polymorphic function, when you're calling one, sure I've got one here somewhere. This is polymorphic, it just doesn't look like it. But, you know, when you're calling a polymorphic function, we have to solve for all the variables. In this case, the variable's invisible. Here, let's go find a... whoops. We don't want the executable file. So, you know, when you say something like X is $T type or whatever, right? We need to do a thing where we solve for $T. And the way that I decided to do this originally that turned out not to be really good was I said, well, you already have to, just to have a statically type-checked programming language, you already have to check two types against each other to see if they match, right? So like even a regular non-polymorphic function, if you're calling the function with some arguments, you just have to have a function that checks that those arguments are the right types. And because types are pretty expressive, that function has to be recursive, right? So if you have an array of something, of pointers to something else, right, then you need to check the array part of the type and then go down and check the pointer part of the type and all that. And so I said, well, it seems straightforward then if you want to match a variable that just when you're recursing and doing that type match process, just have a marker that says there's a variable here. And when you see that variable, you just substitute whatever you're matching against. And it's very simple and it just works. And that was kind of true for a while. However, it means that you have to represent the variables in the type representation. And not just in the syntax of the syntax tree, but they have to be represented as like somewhere in the types which are generated from the syntax tree, right? And that didn't necessarily seem that bad at first because it's like, well, when you bind the variables inside the types, they have to have a representation anyway. You have to say what t is in the type of this function. So why don't we just make a version of it where it's like, well, it's unbound here, right? But there are lots of reasons why this actually ends up being very complicated and hard to think about that were not apparent in the beginning. Like there are weird state variables for having to turn matching off and on or really off. Because like if you say type of t in the middle of your function header, it's like we're recursing down and comparing t, and t might have unbound variables in it, but we don't want to bind those variables because it's a type of expression. It doesn't have these dollar signs, right? So the problem is the job that we actually want to do is pretty simple. We just want to match in the syntax tree wherever these guys are. But once you put them in the type representation as opposed to the syntax representation, you can like have them in places that you don't expect. So I'm hoping it will be much simpler just to be smooth brain and just match the syntax tree. Another reason I wanted to avoid that was you don't want to have all these different functions that have to know about every node in your syntax tree, because then every time you add a node to the syntax tree, you have to modify every single frickin' one of those functions. However, we're pretty far along in the language now. We don't add syntax tree nodes very often. And I mean, if that really is the best way to solve the problem, then it really is the best way to solve the problem, and you should just do it. Does ft pointer to thing conceptually expand to ft pointer to thing $t? Conceptually it does, and in fact that's what the implementation used to do, was invisibly make that expansion, but I changed it so that it doesn't do that anymore because the hidden variables floating around were also causing implementation problems. It was better just to, or I think the current theory is that it's better just to not do that expansion and handle it in the polymorph process. Wasn't I trying to solve this like a month ago? No. I have no idea what you mean, no. Could I please share my thoughts on tools like Kubernetes? Like, look, why do you care? You can't do anything with computers anyway. So why do you need 10,000 computers to work together to do the nothing that you already can't do? That's what I think about it. And I don't mean that as a personal insult because I don't know you or who you are. I just know that all the web people who do this kind of stuff can barely do anything. They just do trivial things that we could have done 30 years or 50 years ago. It just takes longer and it works less well. And so who cares? It's completely uninteresting. Do I know Galactus's pain? I do. I know Galactus's pain, yes. Spicy hot take? I don't think it's a spicy hot take. I think it's an honest take. So I was watching, by the way, there's Battlefield 2042. Let me see if we can pull this up, Jamie. Battlefield 2042 beta came out today. And there was this cool map that was like a city. And I was looking at this and I was like, it was this cool futuristic looking thing. Where is it? There we go. And I was like, it looks really good in the game. Wait, that's the real world inspiration. Where's the, it's like this thing. And I was like, there's no way that anywhere in the US is going to build anything that cool within 20 years. And then I realized it was in Korea and I was like, okay, maybe Korea can do that, but the US can't do that. Like, it was just interesting to see that. Like, here's this science fiction game that happens 20 years in the future, and there's no way to imagine anything this interesting being a setting in the United States. You know what I mean? Like, we just can't do that. It's actually cool that they have an actual, like, you can see how it's like they've extrapolated this setting into the future. Buildings take time to build. Why? They didn't used to. Do I have any information on how much easier it is for a company to get a visa for someone with a bachelor's degree versus master's degree? Okay. For visas, there's a few different types, but there's two major types that you care about. One is the H-1B, which can be harder or easier to get depending on the year, right? And these are the ones that historically got abused by all these consulting companies, mainly from India, but also China, who, like, you know, get not particularly skilled people. It's like, it was really an uneven playing field, and the visas were being abused. But those are the ones that most people come across on, right? Yeah. So H-1B is for sort of normal technology worker. There's another visa called O-1 visa, which if you can is the one that you really should try for. O-1 is like, basically means this is an exceptional person. And so you have to prove exceptionality, right? You have to, like, write a little dossier that says, like, this is why this person is a badass. This is what they've done that most people would not do. But if you can successfully apply for that one, it's smoother sailing. But you have to be able to make a legit case for O-1 status. Do you check at compile time or runtime that the operations in some polymorphic function are implemented? I mean, everything is checked at compile time. It's a statically checked language. H-1B requires masters? I don't think that's true. I believe it requires a bachelor's degree, at least. But I don't think it requires a master's degree. Why do I think that is? I don't know. I mean, I was ranting about this a little bit last night about how most software jobs I knew for, like, I know software better than other fields, but most software jobs that I know are mostly bullshit. Like, people aren't working most of the time. And then when they do work, the work they're doing is mostly ineffective, right? But like, just looking at what people do by hour, they're almost never working. And if that's true for software in the US, it's probably true for most white collar jobs in the US, right? It's definitely true for like construction. Like, if you ever see a construction site in the US, the dudes are standing around not doing anything, right? That's just what a construction site is. So I think we've sort of normalized this situation where people don't really work ever, but they pretend that they work all day, right? And that's just our whole society now. And so why would you expect to be able to do anything? Apart from Boca Chica, yes, notable exception. And look at what they are able to do, right? I do think there's a little bit of a divide within companies. So like, if you look at a successful, like, quickly growing startup or whatever, like, I don't know, Stripe, for example. I know some people at Stripe. Still growing quickly. It's in that phase. Very successful. You know, the people in positions of responsibility in that company work a lot. But like, do I think that like the Leaf level employees work a lot? No, I don't. I mean, I don't really know, but like, it doesn't seem atypical to any other tech company to me in that way. Tech, I said tech, non-sarcastically. Do we maintain a physical office? We usually do. We don't have one right now because I got pissed off at San Francisco, but we'll probably have one again soon. What do I think about the issues that such tools are trying to address? There's no such... I don't exactly think that they are solving non-existent problems, but I think that they are solving problems caused by a lack of introspection and by piling complexity on top of complexity on top of complexity. And their attempted solution to these problems is to pile more complexity on top, which doesn't seem particularly wise. And also doesn't really solve anything. So like, I don't... Like, you can get way more performance out of computers by going under rather than going over. Right? By which I mean, you know, if you're trying to like load balance some service or whatever, you'll get way more performance by like stripping out all the web crap and just writing the minimal system that does what you need to do on one box than by farming it out to 100 boxes. Because you're more than 2 orders of magnitude slow by doing that. You're probably 3 orders of magnitude slow. So, like, what are people doing, right? And the answer is they don't know because they don't spend any time working, so they don't get good at their job. I don't know anything about Starfield. Can't say anything about it. Anyway, I saw this picture and I was sad because I was like, there's no way you're ever going to see that in the US in 2042. RIP. That's all. Damn it, I dared to close a browser window and the whole browser crashed. At some point, you'll have to scale out. Okay, but so what? Why, like, if you need to scale out, why don't you do something simple to scale out instead of a ginormous mess? And do you even know? Do you know how many simultaneous users you would need in order to be forced to scale? How do you manage symbol tables with scopes? At the moment, you have one symbol table for all functions. That's sort of the C way. And then hash the identifiers. Then you have to recursively check the scopes of the identifiers node, and that seems super bad. I mean, I am very dumb with respect to scope handling. Right now, when you try to use a variable, I just start at the scope where that variable is and do the very obvious dumb thing of walking upward, and each scope just has its own scope data. And that might be something we try to optimize at some point, but right now the compiler's fast enough. Do I check at every call site of that square function that t supports times? It's a little bit different from that. What happens is, for any call to square, we generate the version of the function for the appropriate t. And when we generate the function, then when we go compile that function body, we will check that times knows what to do with that type, right? But those sort of happen at two different phases of, not really phases. They don't happen very tightly coupled. Okay, let's try to do some programming. Okay. So we got this function. We got this. We want match solver input. I might need typer for that. Okay, so match solver input. We're just not going to actually do anything yet. Oh, we'll do this. Okay. So we're going to pass this match solver input. Actually, yeah. So we have historically we sort of use these things, which we don't have access to from here. I'm not sure if I want to keep those in the long term, but maybe I should keep them in the short term and just make it work. I'm just trying to think about, like, it seems very straightforward to do this, so maybe I should just plow ahead and not be conservative and backward compatible. But maybe I should be. Maybe I should be. Let's go look at the calling site. So we're going to replace this with a call to bind definers. Now this was a weird thing too, because because we were calling check that types match, we could decide that we don't match before. And I guess we still could have that. We could have like a structural. It's just not quite the same. But I do think we want to return bool. Yeah, this could get kind of weird. Okay. It's just interesting how this was a little tiny snippet of code, and even just adding these return trues and falses is making it a little bulkier, right? It's like, you know what I'm saying? Okay. Hopefully didn't miss things. I don't use a symbol table. I don't know what you mean by symbol table. What does symbol table mean? Okay, now the problem is we need another argument here, which is the actual type that we're binding against. Sag. So and the code gets bigger. So here we would bind to that. I don't fucking know what happens here. Okay. Okay, so okay. This is where it gets difficult and annoying. We're going to assert false here, because I don't want to think about this yet. And then here, this is not even the right place. Let's just, okay. Let's just put this here. I want to do this one. All right. So here, so we're matching, this is where it gets weird, and this is the thing where at the beginning of the stream I was talking about how it seemed weird to like match between the syntax tree and the type tree, but we are going to do this here. So we need to say oh. Well, yeah, I guess that's right. And so we're going to check the sizes of the arguments and returns. And we'll return false if those do not match. Okay. Am I going to port Sokoban to mobile devices? Who cares? Who cares? Okay. So we need to do this. C++, I don't have an index. Fucking. How can they be this bad? Okay. So we pop this in here. Oh. Actually, we're okay with I think we might change this. I am honestly not sure why we store that in the type info. Oh, I guess I kind of know. In fact, I have a comment. Currently want to get it to types block so the lambda pointer is back. We can get rid of the other stuff. That said, yeah, we need to reevaluate all that. Okay. Um, so we don't really need this right now. Maybe bring it back later. There's no way to win on that indentation. All right. Cool, cool. Okay. I kind of want to go outside, so this might be a short stream. But this is one of the main cases we need to handle is, there's a polymorphic argument that's a function type. It's not the only case. We need to handle, well, the blank identifier case, but that's handled already in principle. Well, no, it's not handled already, but it will be. We need to match against struct types. So that thing that we started doing up here, actually, I think we just started doing it. Okay. The problem is this is where it gets gnarly. Because in theory, even though normally we type very boring things here, in theory, you can do any argument naming and stuff and reordering that you would do anywhere. So we kind of need to call sort arguments. But maybe I don't want to support that right now. That's one thing that we kind of got for free from the other way that we were doing it. See, these things tend to reveal themselves as you work on the code. It's like, oh, yeah, because we used to sort arguments to generate the type, then argument sorting was given to us for free, sort of, in that process. How to find motivation. If you don't want to go for a walk, don't go for a walk. Why are you asking me? Why are you asking me why you don't want to go for a walk? Either you do or you don't. If you don't, don't. If you do want to go for a walk, go for it. Like, some things are easier than people make them. Okay, I think I'm not going to do argument sorting yet, but we can add this as a feature later on. We could say for now, we will just bind in order with this one's weird. This one is weird. So the original type that we referred to up here has an argument list. That argument list, right, it's a bunch of declarations. So we want to match those declarations the trick is maybe this can't happen, but I'm envisioning something where as we do the polymorph solve, no, you know what? We're just worried about the simple cases right now, and we want to make sure this works for the simple cases. And then if we need to make it more gnarly for the non-simple cases, we can do that. So the simple case, we've got a struct. We just, okay. So we're going to look through the this is going to break may break on partially baked structs till we sort it out. Okay, so we're going to do another okay. then what? Make a robot that electrocutes you if you don't walk. I don't think that I recommend that approach. I don't think that I do. So we've got so these need to match up to the identifiers in whatever they're just going to be in the constants block. Right. So we can go to scopes, find in block. We're going to do that. See, the thing is, the problem I'm having is we want to take the type in the constants block for each argument. This is hard to think about for some reason, maybe just because I'm slow right now. So whatever this type is, yeah, okay, never mind. We go through the arguments block of the type, not the constants block. Let's do this. Not equal to. So that doesn't match. Let's give ourselves a short name for this. And there we go. Are you allowed to peer review this code? Yeah, I don't know what to say about that. Okay, so this code already, it just got big. It was so tiny, and now it's ballooned a little bit. All right, so we get the thing out of the argument list. And then we get the thing. So it's confusing. There's the calls argument list, and then there's the structs arguments block, right? And then this is the tricky part. The tricky part is there's two structs. There's the, yeah. Okay. Okay. This is really... This is why I've been confused. Okay, so the source thing is not filled out and the target thing is filled out. I think. Okay, so here... So when we bind definers for the procedure type, we are matching against what was passed in we don't even have the machinery to do this yet, so match against the source type of the struct that was passed in. That's kind of interesting, actually. That's a capability that we don't even have in the current system. Like, why is Emacs's syntax highlighting completely broken now? Because it's a trash. All right. So we're going to skip that part for now. We're just worried about the arguments. We check the argument list to see that they're the same length. Then we go over the unsorted arguments from what is syntactically written in the type instantiation. We get each of those expressions. Let's call it. So decal is which struct? It's the target desk, right? And we need, excuse me. That's not right though. That's not, I took a shortcut. Because we don't have, we need to do the find in block here. We need to call this. So we need to go source decal is target entry is find in block interp source decal identifier name and target desk constants block not filled out question mark. This is the kind of thing where back in the original time I was like, oh, doing that would be messy. But actually, you know, if it's about this much code, it's not really messy compared to what we ended up having to do the way this all is currently implemented. So then we bind definer to that. Is that right? No. Not quite. Because, see, this is what's confusing too. The way this all was implemented originally was like, oh, we're just doing all this for type variables like standard ML of New Jersey or whatever. But as things went along, I was like, oh yeah, we need to do constants and literals and all this stuff. And those need to be able to be struct parameters. And they need to be able to be baked into constants blocks and all that stuff. And so we made all that work in the old system. So now in the new system, I'm writing this function where you come along and you're matching a syntax tree to a type. And it's actually not necessarily the right thing because now at this point, we want to match it to a constant. But we know that all these things are constants. So we don't actually want to call bind definers. We actually want to say is the expression that we are matching against a definer expression. And if it is, we bind it to the thing that, so everything up to here is good. And in fact, I can go one more. I can go assert target entry type is a declaration. And auto target decal is static cast as declaration. Target entry. That's good. Now, if it's got an expression, we match. Okay. If it's got an expression, then like we're not doing arbitrary syntax tree pattern matching. So the question is the thing that you gave us I guess there's two cases. It could be a more complex expression, right? It could be like it could be a procedure. Yeah, okay. So is bound to a type, we can recurse and do type matching to multiple variables. Otherwise, we can only match one variable to whatever is there. Okay. Okay. Actually, let's do it this way. If it's bound to a type definition, we do one thing. Else, do we signal an error here? It's not matching. Okay, if it's an identifier, we want to bind this identifier to the expression. And we don't have a place to put this data yet. But this is like, oh, here's an answer. We found an answer for the polymorphism right there. All right, and then this one is, if it's a type, we say bind definers. Interp, it, target expr, target defin, and input. Okay, something like that, except we're going to have to do argument sorting. It's going to get a little bigger. It's going to get a little bigger. Okay, so is a definer ident is simple. Okay. So oops. That's it. Okay, this whole thing. Okay, this is not in any shape to run right now. It is not. We're not writing the output for one. For two, there's probably still some conceptual mistakes that I need to go through and sort out. I just wanted to get a start on it this morning, but I'm kind of feeling like I want to go outside and do some sun. So I think we're going to make it a short stream, and I could come back later today and do some more of this or something. Are there any questions about what we were doing? Any direct inquiries involving WTF is happening, bro? What is binding? It's just anytime you assign a name to a value, that's called binding. Or when you play the video game The Binding of Isaac, that is also called binding. It's just a programming language term that has been around forever. All right, thanks everybody. We will continue this later on. It is a little bit sunny in San Francisco today, so I'm going to try to get some of that before it disappears, and then I will come back and continue on this situation. Thanks everybody. See you later.